Hello everyone, you are watching Code with Shubhajit, and today we will be discussing one of the very important problems and also a very famous problem, which is 3 sum from LeetCode medium series. And let's read out the problem statement and understand what they're trying to say. So we will be given an integer array nums, and we have to return all the triplets, which is nums of I, nums of j, nums of k, such that I is not equals to j, I is not equals to k, and j is not equals to k. Basically, they are trying to say that I, j, and k, they will all be different. Okay, different elements from the array, which will sum out to be 0. Okay, we have to keep in mind that the solution must not contain duplicate triplets. What does that mean? It means that, can you see here that we have, sorry, this one, we have minus 1, 0, 1 as a triplet. This minus 1, 0, 1 is a triplet, right? We can also take this minus 1 and this 0, 1 to create a triplet of which is summing up to 0, but this is not allowed. Okay, that's what they are saying, that these three elements minus 1, 0, 1, they have occurred in a triplet. There cannot be one more triplet which have the same values, even if we have one more minus 1 which can create the triplet with 0 and 1 again. Okay, I hope you are able to understand this. Yeah, but this is possible that as there are two occurrences of minus 1, we can use these two occurrences inside the same triplet, and if that triplet is making the sum up to 0, that is valid. In this case, if you see minus 1, 2, okay, this is valid because the I, j, and k, all the values, all the indexes of it are different. This is 0 index, okay, and this is index 3, and this is index 4. So all of them have a different index, and that is possible. Okay, I hope you are able to understand the basic problem statement. Now we can go to the OneNote and understand more about it. So I have taken a random example and also indexed the array out. Let's take this as array as nums. Okay, and if you see here, what are the triplets you are able to see? I can see a triplet of minus 1, and 2. I can see a triplet of minus 1, 0, and 1. Okay, I can see another triplet of 4, 0, minus 4, right? So these are the triplets which I can see. There can be more, but these are the triplets which I can see. So one thing to understand, that if you apply the brute force approach, the very brute force approach, what comes to your mind for the first time? Okay, that is something like we can have a triple for loop, that is have a for, inside that one more for loop, and inside that one more for loop. So this will be maintaining the ith pointer, this will be maintaining the jth pointer, and this will be maintaining the kth pointer. Now what I'm saying is, my ith pointer will go from this point till index 6. Okay, so it will go till this point, because I have to keep space for j and k as well. And whenever my I is at a certain point, my j will go from I plus 1 till this index, the second last index. Okay, and whenever my I and j are fixed at certain points, my k will go from j plus 1 till the last index, that is n minus 1th index. So j can go from I plus 1 to n minus 2th index, and I can actually traverse from 0 to n minus 3th index. What is n? N is actually 9 here, so index till 8, so the number of elements is 9. So I can go from 0 till n minus 3, that is 0 till 9 minus 3, 6, and you can see here that I can only go till 6. J can go from, at any point I is I plus 1 till n minus 2. What is n minus 2? N minus 2 is 7. So it is going till 7th index. J can go up to here, and k can go up to n minus 1th index, which is this index set. I hope you are able to understand this. Now, whenever we have a certain I, we have a certain j, and we have a certain k, we will sum that out inside this I plus j plus k. Okay, and if this thing is equals to 0, then we will be having an array list answer in which we will add that. So inside that we can add, like in our case minus 1, 0, 1 we can add, minus 4, 0, 4 we can add, minus 1, minus 1, 2 we can add. So these are the things which we can add, right? And whenever this I plus j plus k pair is 0, then we will be adding that. But this is a solution which will take around big O of n cube. The time complexity is big O of n cube. Yeah, definitely we are not taking any extra space, but still big O of n cube is quite time consuming when you are going to implement that and whenever it is running in any system. So we have to decrease that time somehow. The more optimized solution can be a combination of a two sum and sorting with a for loop. With a for loop. I will tell you what I have just told. We will be having a for loop. We have to sort the array, and with that for loop we will be also using the two sum. This two sum I have actually explained in one of my previous videos, I guess some last to last video. I will actually link that in the description, and I will highly recommend you to see that video, because that is something which will clear out how the two sum is working. And here we can actually implement the three sum, and that will be easy to understand for you because you know how two sum is working, so it will not take much time to grasp. I will be explaining a bit of the two sum part as well in this video, but it would be really great if you can go and watch that and come back here and continue this again. So I will write this array again to explain the optimized solution. Okay, so you can see that I have actually sorted out the whole array. I will tell you the reason why, and then I have indexed them out. Okay, so the sorting is required in our case because if we have to apply the two sum, then we want the array to be sorted, because in our case we will be having two pointers which, okay, I don't want to reveal it now because it will be a bit confusing. I will tell you how the algorithm works. Okay, for two sum, just a small glimpse I will give you. So let's say we have the array sorted. Now we will be having a pointer I. Now this is sorted if you can actually observe that. And we have a pointer I, we have a pointer j at the last element, pointer I at the initial element. Now we will sum out minus 2 plus 5. What is that? Minus 2 plus 5 is 3. So let's say if I, for now, if I want that the sum should be equal to 0, all those pairs I want. So minus 2 plus 5 is 3. So 3 is actually greater than 0, which doesn't fit our case. We have exceeded the sum. So in that case, we have to decrease the sum. For decreasing the sum, we have to decrement the j pointer. Why we have to decrement the j pointer? Because this is an increasing order array, or it is in ascending order. Okay, that's why. That's why we have to decrease the j part, because it will actually decrease the element's value, and that will actually decrease the sum as well. So minus 2 plus 2. What is that? That is equal to 0. So we got a pair. So we got a pair with 0 sum. And this is how the algorithm works. Now whenever we found a match, we will increment both I and j, and then we will search more. Now minus 1 plus 0, what is that? Minus 1. In that case it is lesser than 0. Minus 1 is lesser than 0, so we will be incrementing the I pointer to the right, because I know that whenever the sum is less, I have to increase the sum. How I am gonna increase the sum? I have to increment the I pointer, because it is an increasing order array. Okay, so I hope like this explanation helps for a two sum. This is a two sum like approach. Now in our case, what are we gonna do? We will be having a combination of a for loop along with a two sum. Okay, the sorting has been already done. So what we will have, we will be having a for loop, okay, in which the I will be going from 0 till n minus 3th index. So here 9 elements are there, n minus 3 means I will go till here. So the range of I is till this only. Okay, we will write that I is equals to 0, and then I should be lesser than n minus 2. Don't want to confuse you. I is lesser than n minus 2. What does it mean? What is the n minus 2? N minus 2 will be 9 minus 2, which is 7. And I'm saying lesser than, not equal, lesser than, so which is 6. So I will go till 6. Same thing only, just the type of writing is different. You can also write I is less than or equal to, but it will be n minus 3 in that case, because equal to sign came. So it's just a way of writing. You can use both of them, but I prefer to write less than. So that's why. Okay, inside that for loop, whenever our I is fixed in a certain like value, let's say I is here or I is here or I is here, whatever I is, Let's say we have I here, I is 2. Okay, now in that case, our this array, in that case our this array, this whole thing from 3 till 8 is the two sum array, this one. And in this we will be having a j pointer and we will be having a k pointer here, and then we will be applying the two sum approach here to find the j and k pairs to certain target. Okay, and in our case, what will be the target? It will be the negative of this value. Why I'm saying that, let me see, let me tell you the actual reason why I'm telling that. So the nums of I plus nums of j plus nums of k should be equals to 0. That is the 3 points which we have. Okay, understand properly. Okay, so we have this ith, jth and kth index. Now if my ith index value is -1, okay, then what all we need with j plus k to get 0? We definitely need a 1. And how does it came? It actually came by negation or making it negative. Let's say if at ith index we have a 4, how are we gonna have j plus k that will sum out to 0 when we add it with this? That will be a -4. Okay, so what I'm saying is that when we have a 4 at ith index, we want the j plus k to be -4 so that this whole sum will be equals to 0. I hope you are able to understand. So what I'm saying here is the target what we are looking from the two sum, it will be negative of the nums of I. Okay, whatever the nums of I is, the negative of that is the target. And now the j will be from, j will be the I plus 1th index and the k will be the n minus 1th index. That is the last index. Okay, and j will be this index. Whatever I is, the I plus 1th index. So as I have told, this is the two sum array in which we have to find a value 1 whose sum is 1, because this is -1, so minus of that is this, that is 1. So I have to find nums of j plus nums of k that is equal to 1. Okay, so applying two sum over it, can you see that -1 plus 4, what is the value? -1 plus 4, the value is 3. So is 3 greater than target? Yes, 3 is greater than target because the target we have is 1. We want to find 1. So we will be decrementing the k because we need to decrease the sum. So k points here now. So -1 plus 2, what is that? That is 1. So can you see that we have found a pair of j and k whose value is equals to 1. So in that case, in our output, we will be adding that pair, which is -1, uh, -1 and 2. So this is a pair in the output. Okay. Now, as we have found a match, we will increment both j and I will decrement k. So k will be pointing here and j will be pointing here. Okay, that's good. So 0 plus 1, are we able to find one more match? Yes, we are able to find one more match. We will be having one more output, that is -1, 0 and 1. This will be one more triplet. Okay, now we have found the triplet. Now we will increment j and we will decrement k. So both j and k will be pointing to this location only. And whenever they're pointing to the same location, we don't have two distinct elements. We have the same element, right? So we will come out of the loop. Now you have to understand one more point here. If you have also watched the two sum, that will help you. That is, can you see if our I was at this point, okay, or let's say, okay, here also if we take our I was at this point, right? For the next time, I will be at this point. When I will be at this point, this will be our two sum array. And when this will be our two sum array, we will again be having, this 0 and 1 as a pair, which will actually give us a value 0 for the whole triplet, -1, 0 and 1. They are giving a triplet sum 0. So we will be having this, right? -1, 0 and 1 again, which is actually duplicated from here. So we have to handle this case. So in that case, to manage the duplicates, what we have to do, whatever pointer I, j or k which we are having, let's say if I take the I pointer, whenever I was at here, right? Whenever I was at here with index 1, the value -1, and for that part, we have this whole thing as the two-sum array, right? So whenever this has been passed and we have got all the triplets and we have logged them in the output, now I should be moving here, right? But we have to keep that in mind that whatever value that is the -1 we have, now we have to increment I till the point we don't have a -1. What I'm saying is to remove the duplicates or to remove the chances of having duplicates, we actually have to remove it from the ith pointer first. Then we can see the j and k later on. But from the ith end, first we have to remove them. And for that, what we will do, we have a -1 here. We increment it here. We see that, okay, the last value is also -1. So we will increment it till the point we don't have a -1. So for that, I think this is the one, that is the index 4, where I will be standing whenever it has processed this index 1. After that, it will directly jump to index 4 because index 2 and index 3 are having the same -1 values, and it will give us duplicate triplets, right? Okay, so this part is clear with the index I. Now for index j and index k as well, here if you take this, let's say while traversing, this was index k at certain point of time, and I go to this. After finding a match, I go here. So now k is here. But if we see that, okay, wherever I have came from, it is the same element. In that case, it doesn't like benefit me with unique triplets because the same value I am again having. So I will actually decrement my k till the point we don't have the same value. Same goes for j as well. We increment j as the direction of j is this and the direction of k is this, right? So we will increment j till the point we have a different number from the last value. Okay, what where we have encountered a match between j and k. Okay, I hope you are able to understand this. A lot of explanation has been going on and I have created this a bit dirty. Apologies for that, but I hope you are able to understand the actual solution. Okay, now we have to code this out. Okay, so going stepwise, uh, first let me initialize the length of the array to n. Let me initialize the ith index, that is the outermost index, to 0. Also, let me initialize the result or the answer which I will be returning. Okay, so that will be some new. I'm using array list because I have to use some methods like add to add a new array list or to add a new list inside the answers array, right? Because it's an array of array, right? It's a list of list or an array of array. So the output will look something like this, right? So we have an outer array and inside we have one more array. So to put this array, we need, I'm using this array list. Okay, so this one is done. Now the first step is sorting the whole array out because we need to use the two-sum approach along with a while loop or a for loop which is running this variable. Okay, so let's sort it with arrays.sort nums, and now I will be having I is less than n minus 2. I believe this constraint I have previously explained, that I is less than n minus 2 because it has to go till this point, right? This 2. It will keep these two elements for j and k. So now here inside this, what we will do, we will check that what all values our j and k can take. So I will initialize that int j is equals to I plus 1 and int k is equals to n minus 1. N minus 1 is the last index, this one. Okay, so I have set the j and k pointer for the two-sum approach. Okay, now I will also like calculate the target which I need for the two-sum. What it will be? It will be minus of nums of I. Okay, and now I will be running a for loop j is less than k. So this is what we are doing inside here, like inside this while loop, while I is less than n minus 2. This is all we are doing for the two sum approach. This is the initial part of the two sum, and this while loop is the standard two sum, if you have seen the previous video of the two sum approach which I have explained, right? Now I will check if nums of j plus nums of k, if it is greater than target. In that case, what I'm gonna do, if it is greater than target, then I need to decrease the target. For that I have to decrement k. Else if nums of j plus nums of k, if it is lesser than target, what will happen in that case? In that case, I have to increase the sum till target. So I have to make j plus plus, because this is an increasing order array after sorting. Okay. Now in else condition, we know that okay, nums of j plus nums of k is now equals to target. Now our actual triplet has been found, and in this case what we are gonna do, we will first add the triplet in our answer. So answer dot add. So due to this add method only, I have used this array list. Okay, this one. So answer dot add, and inside that we have to add a list like this one, right? So how are we gonna do that? You can take this approach, new array list of what? Integer, and what I'm putting inside that list dot of what will be the values? It will be nums of I, it will be nums of j, and it will be nums of k. Okay, this is done. Once we have added them, we found a j and k with the following target. We found a triplet. Now we will increment the j and we will decrement the k. Okay, that is understood. Now after this, what we are gonna do, we will check that are there any duplicates which are present in along with the jth index. Are there any duplicates which are present with the kth index? So we will be moving k to k minus minus till we got a new value. We will be moving j till j plus plus till we get a new value. Okay, so while j is less than k, and we also have to keep the thing in mind that our j doesn't surpass the k, because that is the case of this while loop, right? We don't want to surpass that case. While j is less than k and nums of j is double is equals to nums of j minus 1, till that I will be making j plus plus. Same way I can do for k as well. While j is less than k and nums of k double is equals to nums of, what will be here, k minus 1 or k plus 1? It will be k plus 1. Why? Because we are moving k towards the left, right? So we will be comparing k with k plus 1. But in case of j, we are moving j towards the right. So we will be comparing j with the previous j minus 1. Okay. So here k minus minus, I will come out of this while j is less than k loop, which is for the two sum loop. And now I will actually check the same thing for I. Now I am inside this while I is less than n minus 2 loop, and I have to also check for the ith part. Are having some duplicates at the ith index. If I explain you here, it is this minus 1, this minus 1, and this minus 1 again, right? So the I will directly jump from here till index 4, as I have explained previously. So we have to manage that case as well. Before writing the while loop, I actually have to do I plus plus, because now the work of I has totally ended. We are at the new index now, and now we will check that okay, while I is less than n minus 2 and nums of I is double is equals to nums of I minus 1. After making that increment, is it that still my I minus 1 and the present element are same? If that is the case, I will do I plus plus. And I am restricting it to the point I is less than n minus 2, because that's the breaking case of the above while loop. Okay. And when this is done, I'm actually done with the whole function, and I will be returning the answer array here, array of array actually. So answer array list here. I hope you are able to understand this. I just want to run this solution. Because it's a long solution, I might have made some errors, but no. Yes, this is accepted. All the basic test cases are accepted here. I will highly encourage you to do a dry run with some different examples on your own. So one more thing I just forgot to tell you about the time complexity which we are having with this. So if you see that we are sorting the array. For sorting the array, the time complexity is big of n log n, and inside this we have a while loop, okay? And inside the while loop we will be having another while loop. So this is a big O of n square approach. In this while, this is a big O of n square approach, and this sorting is kind of a big O of n log n approach, okay? N log n approach. So the total time complexity is big O of n square plus big O of n log n, and if you trim it down or if you round off, it's almost big O of n square because that's the greatest. So yeah, I will highly recommend you to solve this solution on your own and submit it and see if all the test cases pass. Okay, I hope you are able to understand this. If you have any doubts, please comment them down below and I will be really happy to help. That's all for today.